All right, let's take a look at the 11E handout. So more area problems. Um, so let's take a look at the first one, which gives us a triangle. Two sides are 12 and 8, and then the angle between them is an obtuse angle. It's 114 degrees. So um, we have to find the area. Now, there's a hint here that says take one of the two sides you know and draw it horizontally. And typically speaking, I found that starting with the bigger side tends to be more useful for a lot of problems. Um, so I'm going to take the 12, the longer side that I know, and draw it horizontally. So this is 12. And then the 8 is connected to it, and there's a 114 degree between them, 114 degree angle. So it'll be obtuse. So it'll be sticking out like that, 114 degrees right there. So then the triangle looks like, whoop, that didn't go far enough. Looks like this. And we know that the area of a triangle is 1/2 base times height. And the way that I drew it, 12 is the base. But I don't know what the height is yet. 8 is not the height because it's slanted. The height goes straight up and down. So it would be this distance right here would be the height. So in order to get that, I need to drop an altitude and then extend the base so that it sticks out like that. Now notice the 114's right here. So this angle would be 180 minus 114, which is, what, 66? Yeah. So this angle is 66 degrees. And then I'll call the height x here. You can call it h if you want, but it doesn't really matter. And that's opposite, and 8's the hypotenuse, so I'm going to be using sine. So sine of 66 equals opposite over hypotenuse, x over 8. Multiply the 8 over, and we get that x is 7.30836, which is going to go here because that's the height. So if I plug that in here and multiply it by half of 12, which is 6, then the whole thing comes out to be about 43.850. Whoops, why would I? Yeah, okay, 43.850. All right, so that's the first problem. Second one, we got a trapezoid, and they tell you its area. One of the bases is 8 centimeters. The distance between the bases is 10 centimeters. Okay, so I've got one base that's 8. I know that the distance between the two bases, now I don't know if the other base is longer or shorter, so I'm going to, let's just draw it like this. So here's the second base, and we'll connect them. Now it might not be an isosceles trapezoid, so I'm intentionally drawing it so it doesn't look the same on both sides. Area is 150, distance between the bases, so this distance here, the height of it, is 10 centimeters. And we know total area equaled 150 centimeters squared. Okay, so I'm going to do this problem a few different ways. You can kind of decide if you like one better than another. So here's one way of doing it. A lot of people like to chop trapezoids up into triangles and a kind of a rectangle in the middle of the thing. So if we do that, we know that the height is 10. We know that this part in the middle has to be 8. Oh, by the way, the question is, how long is this other base, right? That's the question. So if I look at this part right here, well, I know that rectangle is just going to be 8 times 10. So this part in the middle is 80, right? So I'll do this. We'll call this method 1. So the area of the rectangle is, what did I say, 10 times 80? Yeah, 10, or sorry, 10 times 8. which is 80. Okay, so I know that that's not the whole area. So the leftover area, let me do this. This area plus this area, the two green triangles here, that area, so the area of the triangles has to be 150 minus 80, which is 70. So there's 70 units left, 70 square centimeters left over for the two green triangles. So here's what I'm going to do. I'm going to take these two green triangles and squeeze them together. If I do that, kind of looks like this. 10 for the height. I'm not sure what the base is, right? I'll call that X. But I do know that the area is 70. So of both triangles put together, which is what I have. So the area of the triangle 70 has to be 1/2 the base, which I've called X, times the height, which is 10. So I got 70 equals 5x. So then x is going to be 14. So this is 14 right here. Well, remember the 14 is really this plus this. That's 14. And I have 8 more in the center. So the whole base here is 14, the green parts, plus the 8 in the middle. So the other base equals 14 plus 8, which is 22. And in this case, we're dealing in centimeters. Okay, so that's one way of doing it. Let's look at a second way. So method 2. All right, let me draw some version of this trapezoid again. 8 centimeters here. We don't know how long this one is. And the height is 10. Okay, if I slice this thing into 2 triangles with a diagonal right here like this, I'll call this triangle 1, this triangle 2. I'll call this, and this time I'll call the whole base x. Okay, well the area of triangle 1 is going to be 1/2 its base times its height. Well, triangle 1, if we look at 8 as the base, then this right here is the height. So that's going to be 1/2 8 times 10, which is 40. So I know that the area of this triangle is 40. And if the whole area is 150, then the leftover area here has to be 110. So the area of triangle 2, remember the whole thing was 150, took away the 40, I'm left with 110. And I also know that the 110 has to be half of this triangle's base times height. Base times height. Well, that's 1/2 10 times x. Let's say x times 10, because x is the base. So that means 110 equals 5x. And if I divide by 5, I get x equals 22. And notice x here is the whole base, so the whole base is 22 centimeters. So that's the second way of doing it. Let me do it a third way, and you can kind of decide which way you like the best. So let me shrink this down. All right, so here's the third way. Here's a third way. I'm sure there's more. All right, so this way, let's take the trapezoid. Let me exaggerate this a little bit more. Now there's a formula for an area of a trapezoid that is in several textbooks, and it looks like this. 1/2 b1 plus b2 times height. So the question is, where does that come from? Well, here. This is 8 centimeters up here. Let me draw this line right down the middle. you might remember that's the median of the trapezoid. That's called the median. It's like the midsegment of a triangle, and it equals the average of the two bases. Right? So it would be 1/2 a plus x, or a plus x over 2 if you wanted to think of it that way, if the base is x, the second base is x. Okay. Well, the height is 10. Here's how I'm going to cut up this this trapezoid. I'm going to cut it right here and here. I'm going to take this triangle and put it right there. And I'm going to take this triangle and put it right there. And what you'll notice is I've created this yellow rectangle as a result. Right here. And the width of the rectangle, the height is still 10, right? The width of it, though, it's not 8, it's longer than 8 because it's got this blue part on the left side and the blue part on the right side. And it's not x because I've taken away the blue parts. It's the median. It's the average of 8 and x. So it's the average of the top base and the bottom base. That's this part. That's how long that rectangle is. And then I'm going to multiply it by the height of the rectangle, 10. So this becomes the area of the trapezoid is 150, turns into 1/2 8 plus x times the height, 10. So if we work this out, let's see, half of 10 is 5, so 150 equals 5. 8 plus x, we could distribute 150 equals 40 plus 5x. So 110 equals 5x. So then x equals 22. So we've got 22 centimeters for the length of the other base. 3 different ways. All right. Okay. Let's take a look at the next one. Okay. Total area of the triangle is 40 square inches. The big triangle, by the way. This whole area. Find the area of the smaller triangle on the right, the one that's white here. Okay. Well, to get the area of a triangle, we need 1/2 base height. So for the big triangle, that's, by big, I mean the whole triangle, right? That's going to be 1/2 the base, which is 10, times the height of the triangle, which we don't know, but it's whatever this distance is. And we know that the whole area is 40. So this is 5h equals 40. So now I know h has to be 5. 8. Okay, so the question is, what's the area of the unshaded one? This one, right? Well, I now know the height of the triangle. It's 8. So area of the unshaded triangle is going to be 1/2 its base times its height. So that's half of 32 is 16. So this is going to be 16 square inches. In number 4, this is one last new idea here. You randomly choose a point from inside that big triangle. So the idea is you're randomly picking a point inside here, and so they all have an equal chance of getting picked. Like, you're just as likely to pick this point as you are to pick that point. Okay. So the question is, what's the probability that it'll be in this triangle, the one with the 4 at the bottom? Okay. So probability, that's like, what's the odds that you picked something out of the white? That's kind of what it means. It's technically not actually the same. What percentage chance do you have of picking the point in the white region? That's really a better way of phrasing it. So the way to figure that out is to figure out, well, what percentage does the white region take up? So to get the percentage the white region takes up, we need so probability of point being in the unshaded. Well, that's going to be the percentage that the white part takes up. So we're going to do the area of the unshaded over the total area. All right, this. Unshaded area over total area. Well, the unshaded area we figured out was 16, and the total area was 40. So if you could say 16 to 40, you could reduce it. That turns into, they're both divisible by 2/5. Or you could turn it into a decimal, 0.4. Or you could say 40%. I'd be okay with any of these answers right there. So we'll say 40% or 0.40. I think the percentage and the 0.40 are the most common ways you tend to see. Well, what's the probability of the point being in the shaded region? You could do the same process, figure out the area of the shaded triangle divided by the total area. Or you could say, well, it's a 100% chance of getting it in anywhere in there. And I already know it's a 40% chance for this one. So this side's got to be 60%. Or 0.60. Okay. Let's do the very last one here. The quadrilateral is a square, so if one side's 4, they're all 4. And all angles are right angles. And let's see, what else? And the shaded region is a sector of a circle, which means this guy right here is the center point of the circle. So you could kind of picture that the circle would look like this, right? So the question is, what's the area of the shaded region? Well, if it's part of a circle here, it's a sector of a circle, and we know the angle is 90, then I can say 90 over 360 times pi r squared. R is 4 in this case. So if I plug that in, that's the area of the shaded. So if I plug that in to a calculator, that ends up being 12.5664. So 12.5664 centimeters squared. So then the question is, what's the probability that if you choose a point inside the square randomly, that it'll be in the shaded region? Now, you should be able to tell, like if I chop it right here, well, this is 50% right there. That's half the square. So it's got to be bigger than that, maybe like 60, 70, somewhere in the 70% range. Because this looks like it could even be more than half of what's left over there. So even more than 75% possibly. So let's take a look. So we need probability of shaded, which is really another way of saying what percentage does the shaded region take up. So it's going to be the area, it's going to be the shaded area over the total area. Well, the shaded area, we just figured out. It's 12.5664. The total area is just 4 times 4, right? The area of the square is 4 times 4, or 4 squared, by the way. That's why it's called squared. So 16. So this over 16, you plug that into a calculator and you end up with, let's see, 0.7854. Yeah, so 0.7854. Or if you converted that to a percent, 78.54%. All right. I hope that helps a little bit, and I'll see you guys soon.